Hey, welcome everybody. It's time again for Making a Connection, the Antaira podcast. Right here in Orange County's only community radio station, octalkradio.net. And today, well, we're going to continue the conversation. We're going to dive deep into that rabbit hole that's called the industrial internet, the Internet of Things that we're all hearing about, and the things that go into it, the things you wouldn't think about right away. And today, as always, we have an expert here from Antaira, and he's going to talk about something. You're going to shake your head and say, oh, come on, this can't be that important. He's going to talk about the cabling. What kind of cabling you connect your internet devices, particularly the, what do we call them, Ethernet switches? Is that what you guys make here?
Correct. We make Ethernet switches, converters, media converters. So we make a slew of internet-connected products.
Okay.
That provide connectivity.
Well, Henry Martell, thank you for joining us here today. And thank you for wearing a mask today. I appreciate that. We're in a little tiny room here, and Henry says, no, I feel comfortable. Wear a mask. So if it's a little muffled, everybody live with it here, because Henry's being a good guy and doing a good thing here for all of us today here. So having said that, you do look like the masked marauder. You look like the guy that comes, the masked superhero that comes in and saves the day. Let's talk about, first of all, the whole world is moving to internet connectivity, this Internet of Things, where my toaster, my TV, my car, my little robotic vacuum, that's in the consumer world. And in an industrial world, it's even bigger, right? Everything's going to be on the internet.
Yeah, it is. And you find yourself, being in the industrial industry, you find yourself in situations where you never knew internet existed or connectivity was required.
Or you'd never think about it. For example, there's behind you is the graph of some of the things, industries you guys play. Now, you guys just make these Ethernet switches, right? This is the final piece that allows you to hook up a cable or Wi-Fi and make it go to the internet, right?
Yeah.
And that would seem like the simplest of things. But look at some of the industries you guys are working in there. All these little infographic on the wall for those that are listening and can't see it. We got windmills, we got solar, we've got buses, we've got factories. I mean, all sorts of very sophisticated things. And the key is, in all those areas, what? It can't break. It's
Right.
got to stay up all the time, or the buses crash, or the street lights aren't coordinated, or the factory doesn't work. This stuff can't fail. And that's one of the key things that people don't think about. I'm just going to go to Best Buy and get an Ethernet switch. I don't need something sophisticated, but they do.
Right. And most people don't understand industrial industry or the industrial Ethernet portion of connectivity or portion of the internet.
Why would you? I'm spending all my time trying to design this complicated system to run my factory, to run my transportation grid, to run my prison systems, to run my solar farms, all this kind of stuff. And the last thing I go is, all right, let's get some kind of, I guess we got to have a Ethernet switch. Something's got to hook it up to the internet and send the signal. And let's just get any old cable down at any old supply store and plug it in, right?
Yeah, and most people do that. And for the most part, things will work up to a certain point.
For a while.
For a while.
That's the key thing. But this is stuff that can't break. It's got to work all the time. It's got to have backups. It's got to have redundancies to it, because these are critical systems. And it's got to do it in a rough, tough world that is, well, we list a couple of them here: high vibration, oil resistant, hardened to heat or cold. These are not just home cables and home Ethernet switches. They've got to live in severe environments in many cases, right?
Right. And most people don't realize that there is a special type of industrial switch for an industrial application.
Exactly. All right. Well, that's what you guys do, this one little cog in the wheel, but what an important cog it is. So we've talked before about some different aspects of it. Today, we're going to talk about what seems like even more of a throwaway discussion. Hey, get some cables. Where do we go get some regular? Let's get some. We got some cables in the back there, don't we? And we plug them in. What happens when you just get regular old Ethernet cables? I don't care, Cat 5, Cat 6, whatever the new Cat is, whatever the new category. Does that work? Does it work forever?
It doesn't work forever, and in most instances, it won't work at all. Well, it'll work part-time. Let me back that statement up really quick. When you typically have a Cat 5 or a Cat 6 cable, and you're running it from a station to a location,
Right.
It's just a cable run. So when people talk about different cables, they usually talk about the difference between a Cat5 cable, a Cat6, and maybe a Cat6A cable.
And which is what? Just how much throughput, how much data it gets through, or are there other aspects? What makes Cat 5 different than Cat 6? Why is Cat 6 better, or is it?
So it is better in a sense where it does hold more bandwidth and you can process more information.
Okay.
So your Cat5 cable, Cat5e is going to be your 100 megabit cable. Your Cat6 is going to be your gigabit cable roughly, and your Cat6a is going to be roughly about your 10 gig
So
cable.
it carries more data. It's not literally fatter, but it's figuratively fatter. I can jam more stuff through it here.
Correct. And when most people talk about getting the right type of cable for your application, it's, do we get the Cat5? Do we get the Cat6? You know, what version of the cable that we're getting? But they don't realize there's a lot of specialty that goes into the cable, and it's dependent on your environment and the application that you're running it on.
All right, so that's one thing. So what would an industrial cable look like? Does it have a different name to it? Does it have a different category to it?
Well, typically, you got a Cat6 cable is going to be a UTP cable, or it's going to be just your standard cable with the jacket. Comes in two flavors, low smoke for anything above a second floor. It's called the plenum cable, and that's just as in case there's a fire, the jacket burns a little slower. It's
I had
produces less
no
smoke.
idea. They actually have different burn rates on different cables here. Okay.
Yeah. And then besides that, then you have the inner workings of the cable.
Yeah.
What most people don't realize is that you can actually get a cable, and there's certain types of cables that have a braiding around them to kind of absorb electromagnetic interference. And then on top of the braiding, there's aluminum foil around the cables, around the specific pairs.
Who knows?
which
It's
also-
under this little plastic wrap or whatever. It just looks like a plastic wire to me.
Right, so and most people think that. No, unless you've actually opened up a cable and scaled it back, you don't realize that how intricate the cabling is, and all the little pieces and components that go inside the cable.
So let's talk about, all right, you're bringing up a lot of stuff here. We're going to, hang with us, folks. You're going to know more about cabling than you ever thought possible here today, and me included. So there is different kinds of cable. Some of them are built for industrial applications. Some of them, even home cables, have different burn rates and stuff on the outside because you don't want, depending on heat or whatever. Now, but inside the cable, that's where we're going at now. Shielded versus unshielded. You're shielded with a mask here today. You're
Right.
keeping, if you got little bugs, you're keeping them to yourself here. Does that what a shielded cable does? Does it keep the data in, or does it keep bad stuff from coming in?
Actually, so
Outside.
the shielded cable actually works both ways.
Okay.
So, and you're in an environment, for instance, an industrial plant, right? Or you're next to elevators, or you're next to a controller.
Right.
You're next to, you have a cable run next to some kind of, device or some kind of element that's producing a lot of electromagnetic energy.
All right. Let me get you to move over a little closer to the mic there. There you go. Okay. I don't want to miss any of this. All right. So you're producing a lot, because obviously this is electrons. It's electricity. Well, it's not. What is it? I don't even know what's going through this stuff. These Ethernet cables. Are they
Yes.
copper inside? Or
So, yeah, they're copper inside, and it's all voltage, right? It's just it's like miniature pulses of electricity that are running through the cable. But you're talking.
And like any electricity, it leaks out of the wire.
It does leak out of the wire.
Okay.
And so when you have a large cable run and you have a bundle of cables, right, you have what's called crosstalk. So if you have a bundle of
Crosstalk. They're talking to each other and they shouldn't be here. Yeah.
correct, and so that actually causes interference with your cables.
Not bad.
So if you have a bundle of cables, for instance, running by an elevator, right, and you have one cable that's actually running closer to elevator than other cables, what will happen is as that elevator is going up and down, that cable will absorb some of that electricity, and as it goes
And
through
the
it,
little electrical signals and impulses that command that elevator, and suddenly it's sending weird data, not just to the elevator. It knows what to do with it, but it's taking this data, these little electrical pulses that are meant to move the elevator, and now it's contaminating my other signal here.
right, and so then you don't realize why you're getting some type of jitter, or your phone is breaking up, or
Yeah.
you don't realize why your internet's slow. And you didn't realize that 30 feet out of your office, you have a cable run that's going by an elevator, and every time it goes up and down, it's causing interference.
We had this here. We're an internet radio station. I got to tell you, when we cabled this whole thing together, what a nightmare. There are these 60 cycle hums, they call it, and things that pick up this other noise. And I got to isolate the cables, and I had to put little filters on the cables, all this stuff, because the cable was filled with noise.
Right. So imagine now you're in a manufacturing plant, right?
Yeah.
You got robotic arms moving machinery around, right? You got big pumps, you got big motors that are going on. And you don't know that, hey, you got a cable run that's maybe 20 feet away from that, but you're still getting all that interference. So you got cables designed with an outside jacket, maybe braided, and have aluminum foil that protects the data going through, the integrity of the data.
Right.
So as calls are coming in or whatever
And it's not just keeping the data in, so I'm not losing it. It's protecting it from being contaminated from without, from interference coming in and screwing it up. All right. So is industrial cable stronger, tougher, better wrapped than regular old home cable,
it's
business cable?
it's not it's not better wrapped than, let's just say, an enterprise cable. Use your standard cable.
Right.
It's just like special purpose. It's built for special purpose. The wiring, the gauge of the wire is still the same. The plastic that surrounds the wire is still the same. All the copper leads.
Right.
But it's the jacket. It's what's inside the jacket. And it's that foil that really separates the quality of the cable. And most people, when they're building their systems or bringing the network online, the cabling is the last thing in their mind, right?
Wouldn't think about it. Just get some cable. Let's get the cheapest we can. We're going to get it in big long runs, because that's the other question I have. Does it? Again, my home, maybe I got a 5-foot run. In the studio, maybe I got some 15-foot runs here, but I don't have 50-foot runs. I don't have 100-foot runs, or I don't know how far can the cable go? I don't even know how far it'll carry a signal before you run out of steam.
Right. So we'll call that attenuation. So the cable slowly degrades after a certain length.
Right, exactly.
But all cables are
Much better way of saying it than I was struggling to. Okay.
Yeah. So cable is typically rated at 100 meters or 328 feet. So that's your guaranteed your throughput.
It'll work for 100 meters or 328 feet. All right.
Yeah, but if you get but for smaller amounts of data, for instance, if you got like a scan gun, I've seen cable runs go up to like 400 feet, because it's all just a little scan, just a little bit of data goes through. It's not a continuous stream of data. It's just something that happens every once in a while.
Right.
Or a palm reader. It's just a small amount of data. But within spec.
And those are probably on the periphery of the plant. Those
Right.
are on the outside of the plant. You're reading somebody's palm as they enter for security or whatever. It's not maybe right in the central part of it here.
Right. Or like, for instance, like a small little sensor somewhere. Right. I've seen cable
sensors.
links go real far, but there's problems when you get to that point, especially when just a little bit of interference will cause a little snag or cause a little bug in the data transmission.
And suddenly it's not working.
Right.
And you're getting false readings. You're getting bad data. You're getting confusing answers, or it's not opening or closing or doing it. What the heck is wrong with this thing? It's just because there's interference in there. So that's shielded cable. And do you guys then go find special purpose, special run, extra rugged, tough, I don't know, shielded cable that'll work in those situations? They must make lots of different cables, and more than I think they make.
They make a variety of cables. So in our position, we don't typically get involved with that aspect of the cable runs or the installation. We're more
But you're going to diagnose the problem and say, hey,
yes,
you wonder why this ain't working? Look at that crummy cable you got there.
Yes.
Where the heck did you get that thing? Because you guys don't make or sell the cable, but your system won't work if the cable's wrong. Because it's the old, now you're too young to remember this, but I'm much older. I remember the original Christmas lights when I was a kid. Hundreds of light on the tree, one bulb would go out, and the whole thing was dead. It was only as good as the weakest link. Right. And so we've got this spectacular system set in place. We got rugged industrial switches, Ethernet switches, all this kind of stuff. We've got all this stuff figured out perfectly, but the cable stinks, and that sinks the whole system.
It does, and typically we get that call. Hey, your networking switch isn't working. We're having communication problems.
Yeah, your switch isn't working. It must be your switch's
right,
problem.
Right.
Right.
It's never the customer. It's never the end user. It's always our problem.
It's never operator error either. That's my wife would always tell me. Hey, the stupid computer's broken again. Is it the computer that's broken, or is it the operator that's broken here?
Pretty much, and we get that a lot. And we have in the industrial industry, it's really unique. We have a lot of enterprise admins, brilliant guys, really smart guys that come over from the enterprise world.
That's the world you came out of, right?
I came from the telecommunications enterprise.
Right.
And then I come into industrial, and so you got to kind of rethink how the process and rethink how networking works, because there's a lot more interference. The industrial side isn't really about privacy, isn't about secure. I mean, it's about security, but it's more about function, right? I have my my system here, and my job is to make the motors turn on and turn off. Or my job is to watch the sensors so the tanks are full and they're not full.
Yeah.
So it's not necessarily connecting to the internet, but it is communication. It's just a different form of communication.
I see. So you're less worried about somebody hacking into the thing, although that's still a concern because people want to do mischievous things and bring down systems. Like what was the crazy one out east for ransom? They shut down some gas pipeline or
Right,
something
right.
there. So you never know. There are those bad actors out there, or people just think this will be fun or somehow hack into it. But a lot of it is just trying to make it function. Because unlike here, I'm not trying to do anything except, well, I guess I am. I'm trying to turn a TV on. I'm trying to turn a monitor. I'm trying to convey information. But I'm not making a robotic arm move. I'm not watching a sensor. And if it's wrong, the tank overflows or underfills and some bad thing happens. So you're really trying to communicate, and that communication breaks down if the cable breaks down.
And people don't realize that, and that's the funny part.
I
People
wouldn't.
never thought to invest in cable. They a lot of times we'll have customers that will go with the fiber optic cable,
Right.
and that's a great choice because it's made out of glass.
We talked about the last time here. Yeah.
Yeah, it's impervious to electromagnetic interference. But a lot of
Because
times
it's
with
light, it's not electricity.
Right.
It's photons instead of electricity, electrons.
yeah, but for the shorter runs, right? I don't need fiber cable to go 50 feet,
No.
right? But in that 50-foot distance, I can have a pump, I can have a motor, I can have a controller, and when something moves or something turns on, I'm gonna get interference.
Do people try and go cheap? They must try and cut, because I spent a ton of money on the software, and somebody's designing the system, whatever they call these guys who lay this all out, and special software to run it, and et cetera, and your switches and everybody else, all this other gear. At some point they must go, let's just get some cable. Let's
Yeah.
save some money somewhere here.
That happens all the time.
I'll bet. All right, so that's shielded cable. Would anybody in their right mind use unshielded cable? And if so, when or why?
So unshielded cable is typically for your enterprise, right, in your office, right? Or the unshielded cable might be go from the wall outlet to your phone or your wall outlet to your desk.
Because it's a short run.
Short run.
There's nothing around that's going to interfere with her. You can see if there is. It's predictable.
Right.
And so maybe you can get away with the unshielded, which is probably cheaper.
It is.
And so there are some applications where unshielded might work. But here's what surprises me. You guys must walk in and see it all. Because somebody designed this whole thing. They spent a ton of money installing it, setting it all up, and now they're kicking it and it won't work.
Yeah, that happens more often than I'd like to admit, but we've had customers where they can't figure out what the problem is. Our switches are only functioning part-time. These cameras keep going offline, and we can't figure out what the problem is. And
Right.
it's not the camera. It has to be
Because
our
you take
network
them out,
switch.
you test them separately.
Right.
No, the camera's working fine.
And-
You got to find the weakest link, and it's always some little tiny little part that you didn't think about, like the cable, perhaps.
Right.
All right, now, all right, we got shielded and unshielded. I get it. Interference. Let's talk a little bit about hacking. We didn't necessarily, just for a second, as much as I'm not worried maybe that somebody's trying to hack in and mess with my sensor or my switch, they could.
Yeah.
And more they're doing this for ransom or for other evil purposes or something. Is it better than does shielded keep them out? Is shielded harder to break through? Or is that a whole different ballgame? They're going to attack the hardware and not the cable.
Yeah, that's going to be a whole different ballgame. Because the cable is just transport.
Right.
So your cable is going to transport data from point A to point B. So if someone's going to hack into your system, they're going to go in through some type of email. They're going to set up some type of Trojan, some type of backdoor where they can come in, and it's typically at the software level.
Access it through the software. You either use the hardware to access the software somehow, or it's some trick to get in and get into the software. Because I was wondering, I'm going to sound silly, you're all going to laugh, but I don't know how people hack into these things. I don't know if you can just put a clamp on a cable and somehow, because it's unshielded, get access to that electric flow or change that electric flow.
You can tap, if you have access, you can tap a cable. That's done. You can actually do it on a fiber as well. You have these little special clamps. And
I was
don't know
going
if
to
you
say
have too much
Viber, you
information,
can't do
yeah,
that for a bit.
You can actually you can tap into the cable, and when you have, for instance, when you have a shielded cable and someone does decide to clamp or get involved with that, you will see a performance. You'll see a performance degradation, and so there's something.
Somebody's
somewhere.
tapping this in somewhere. The water ain't flowing through the pipe as fast as it should or something.
Correct.
Okay, so part of it is performance, part of it may be security, but I guess a lot of it is function, because you're dealing in environments I never thought of. This cable wasn't designed for oil resistance,
Right.
high vibration, machines are shaking it and rattling it or something here, heat or cold, or what else? What other kinds of environment? I'm not, my mind is racing. I bet there's a million variables that enter into this.
Well, the big one is corrosion.
Corrosion, okay,
Corrosion. So
never would
with a
have
lot
thought
of
of that one.
gases, a lot of corrosive environments, and typically, where they're mixing chemicals or doing something along those lines, you'll have a cable run that people forgot about that was installed a couple of years ago, and all of a sudden,
Something's eating away at it.
something's eating
It's
away at it.
dissolving.
Right? And then before you know it, there's a performance issue, and then we get that call. Hey, your switch.
How about something
they're
silly
working-
like rats? Do rats ever chew through it or anything?
Squirrels.
Squirrels, oh.
Squirrels like to chew through cable. It's just one of those things. And I've seen squirrels chew through everything. So there is really no cable that. Well, let me back that up. There is a cable that they actually sell a metal jacket. It's an armored cable.
An armored
An
cable,
armored
why
cable,
not? Of
yeah,
course,
so
to
that
keep
armored
the
cable goes-
Because you think I got this big factory and there's a mouse back there, a squirrel or a rat or something that's just thinking this is a snack and is chewing through it here.
Yeah.
Well, okay, so we got lots of crazy things we got to harden these cables for. Maybe even put a metal jacket around them if that's a problem. But they got to resist oil. They got to resist. How about heat and temperatures and stuff like that? Do they perform differently when they get cold or hot?
Typically, there's operating ranges, just like anything else. The higher the heat, there is a little bit of network performance degradation. You'll see things kind of drop off. But if you're if you're outside or you got cables running, it's like 180 degrees outside or 150 degrees outside, you're typically going to use wireless or some other way, some other medium to transport, because when you get to that point, the jacket's going to start to get soft and other things will start to melt. So
Yeah.
it's in that space.
So maybe you got to go But Wi-Fi always seems less secure to me. I don't know. Is that really true? Is Wi-Fi easier to hack into than a hardened cable? And it seems like performance is different. I know even here, if we're trying to get a certain throughput when we're sending out a signal to the internet for our internet radio station. It's dramatically different if I put the hard cable on versus the Wi-Fi, no matter what they tell you.
Yeah, you know what? You typically do get better throughput with the hard cable than with the Wi-Fi, but there's ways to adjust Wi-Fi. There's always ways to kind of manage to trying to get the signals pretty close.
Last question. All right, so is all cable the same, and do they have the same connectors on the end? Are the connectors just, do you ever have to change is it the cable or is it that little connector that?
And a lot of times it's that little connector.
I
So
would think,
typically when you have a cable, it's an RJ45 connector. It's that little plastic, a little square
We've all
thing with a
seen it.
little
Looks
tail.
like what used to go into the phone lines. Yeah.
Right. And so we have what's called M12 connector. So imagine a connector that's round and actually screws in. So that's good for transportation, for instance, right? You're on rail or you're on a bus.
And it's rattling and shaking, and it starts to pull out and come
right.
apart. Yeah.
And that happened. That happens a lot, right? People don't realize that vibration will loosen up that RJ45 connector, and you start to have signaling problems, or you start to have communication problems. But with these little M12 connectors, it's just like a little barrel with a little screw on top of it. And you insert it and you screw it and you lock it down tight.
We have the same thing in our audio gear here and our big boards and all the stuff they can't see, but if you look at them, the cheaper boards you plug it in, the better boards you screw it in.
Right.
And it holds it on forever because stuff does rattle, shake, move, bump, and all of a sudden you're wondering, what happened? And you got to go through this giant schematic in your mind here. You start at one end and you test everything. Is it this? Is it this? Is it this? Is it this? And often you get to that cable part and you don't think about, it's just not plugged in. I had that happen the other day here. Something, I don't know why it came out. I still can't figure out. But all of a sudden I couldn't get a signal through. And I went through every gyration I could. And finally I unplugged it and plugged it back in and it worked.
Yeah. So now imagine that's on a bus, right? Or you're on a train. It's just nonstop vibrating. It's for hours and hours at a time. And so, yeah, the connectors really do matter. And there is a difference, especially, like you said, we're in industrial applications. We're on a windmill, we're on a bus, we're on a train, and that signal cannot fail.
Can't fail. Okay, well, that's the key to this whole thing. It ain't as easy to make a connection as you think. We all want to make connections these days. We want to connect everything we can think of. But too often, we're overlooking the simplest things that can bring the whole system to crash. Again, it's the weakest link theory, folks. And if it's the cable or the little cable connector came out or it broke or disconnected from the cable or it's just not shielded properly and it's getting interference, or it's not operating under this environment, or the rats are chewing through it, or a million other things here. How do you guys come in and analyze this, or do you just throw up your hands and say, not us, go get somebody else?
Well,
My piece works fine. Not my problem. Call somebody else.
Typically we like to get involved with the customer, and we like to help troubleshoot until we get to that point where we spun our wheels and we've done everything that we could. And at the end, when all else fails and we're still having problems, we recommend them getting someone on site to kind of take a look, because typically, we have a customer in Georgia or in Texas or Michigan, and they're telling us about their connectivity problems.
Or in Poland or some other.
Or in
You
Poland,
got
right,
offices in
Saudi
Poland.
Arabia.
And those places
Right,
like
we have
that.
customers all over the world.
Eastern Europe, yeah.
Yeah, and we will go as far as we can go. And the one thing that's really, I think it's pretty neat that's on our switches is we actually have a cable integrity tester.
A cable integrity tester.
Right.
The little device itself will spit back an answer and say, hey, this doesn't look like a good cable to me.
Well, what happens is, so there's a special button under diagnostics. And if you're having problems, let's just say we're connecting to a device, and you hit the little button, it'll actually send a signal back and come, it'll send a signal across and it'll come back. So it'll tell you, hey, roughly your cable's at 100 feet. And it'll show you all the different pairs, right? Because our cable has 4 pairs to 8 leads. But if you can time it just right and you hit it, and then you can catch that interference, you'll say, hey, the cable stops at 30 feet. Well, if I know I have a 100-foot cable run, and I'm getting my cable stopping at 30, well, that kind of gives me like an idea of where
Somewhere
the interference
around
is
here.
coming
Oh,
from.
there it is. There's
Yeah.
where the rat chewed through it.
Yeah, it gives you an idea on the troubleshooting. It makes things a little easier.
How cool is that? Well, I think that's one of the things that I found interesting as we've been making this series here, this season of shows, on what most people would think of. Who wants to listen to this? This is the discussion people should hear, if for no other reason than to just raise some awareness of the little stuff that can fail the system, because it's the weakest link. Only one little piece can bring down the whole puzzle here. And what I appreciate is you guys aren't just making these things and shipping them, and I suspect others are. That might be cheaper, but you got guys like Henry here. They're going to come out and say, okay, Henry, figure, because first I'm going to scream at you. It must be your device. It's your piece. It's wrong.
We get that call.
Yeah. And then
We
you come
get
out
that call.
saying, no, it's not this. I swapped it. I tried it. I tested it. But most people would walk out the door and say, ain't my fault. Go find somebody else. And then you got 12 people all pointing at each other. It's his switch. It's his cable. It's his software. It's his hardware. It's his computer. It's his something. And everybody, I hate that. I have that happen in my house. I've had it in my business, where everybody comes out and they stop when it comes to their piece. But it sounds like you guys will go a little further than that. Maybe even you got something built in to help test it and whatnot.
Yeah, and we do. We try to deliver. We kind of over-deliver with our customers, just because we want to show that, hey, Antaira, we're not just going to sell you a product, but we like to kind of we're partners together in this,
Because otherwise I'm going to throw yours out and go buy another one here.
Right, exactly.
And may be nothing wrong with your part. It may be something much simpler than that, like the industrial Ethernet cabling. Well, thank you, Henry, for coming in today here. Even through the mask, I got a clear picture of what is otherwise a world I would never think of. The world of industrial cabling in these giant factories, these can't-fail applications, and how important it is to do this right and to get it all right, because 99% doesn't cut it, right?
Right. It's got to be 100%.
Got to be 100%. All right. Well, I'm 100% in, sold on you guys here. Thanks for coming by, and stick around, folks. We got more of these stuff that you've never thought about, worlds you've never seen. As we get in future editions, we're going to talk about some of the specific applications. I'll bet you guys have had some wild places you've installed this stuff here.
We do. We're in some big places, and we're in some unexpected places. Believe it or not.
Unexpected. Give me one. Give me one that, as anyone pops into your head, you just say, wow. I tell people at home, you would have never thought we got this thing here. You're in a top of an oil derrick, or at your bottom of the ocean, or some other crazy place.
I can't name drop, but I'll give you this.
Yeah.
Where it's a nationally televised sport where silence is golden. When you have people with sticks trying to hit a ball into a small
Okay,
hole.
I kind of think I see that one. Yeah.
And so we have our switches that can run off battery packs, right, instead of generators, because generators cause a lot of noise. And so we have our switches that are silent, and we have this big partner that we work with, and they use our switches.
Because as a key time, it's got to be silent. Well, I want to be silent no more. I want to come back and hear more about this stuff. How do they reach Antaira if they go to you guys? What's your website again here?
Oh, it's Antaira.com.
Antaira.com. That's
find us online.
Antaira.
Yes.
Antaira.com. Well, thanks so much for coming by, Henry Martell, and enlightening us as to the importance and problems that we might run into with industrial Ethernet cabling as we try and make connections with the world around us. Thanks so much. Well, there you have it, folks. A discussion you didn't think you'd find interesting, but I sure did. Industrial Ethernet cabling. Who knew? It takes a lot to make a connection. We invite you to join us each and every time here. Brought to you by Antaira. Right here in Orange County's only community radio station, OC Talk Radio. .net.